7 over 12. Now let's look to see if that's true. I'm just going to look at this fraction right here and see if I can reduce that fraction. Is there a number that goes into 3 and 22? I'm going to say no, there's not. Okay, so that one is reduced. But let's go ahead and look at this one. Is there a number that goes into 24 and 6? Yes, they're both even. That means that 2 goes into them. Well, how many times does 2 go into it? Well, 2 goes into 24 12 times, and 2 goes into 6 3 times. Okay, so now we still have this 22 over 3, but is that the same thing as 12 over 3? And the answer is no, it is not. That means the constant of variation, which is y over x, right, is not the same. So this is not a direct variation. Okay, and we proved it both graphically and through the use of a table, which is what you're going to have to do for your homework. All right, great. Let's go ahead and look at a different example. Okay. We are going to be determined whether the data shows a direct variation. So we have distance traveled by a train. Here's the time in minutes, and here's the distance in miles. So the first thing that we're going to do is we're just going to graph this data. Okay, we're going to show this two different ways. We're going to graph it, and then we are going to look at and see if the ratios have to be proportional. And really what we're looking for is that k is equal to y over x. It has to be the same k every single time. So we have 4 points here. This is our x and this is our y. So we're going to graph those. 10, 25, 20, 50, 30, 75, and 40, 100. All right, let's go ahead and graph those points. So 10, 25, I have this in tens, my time is in tens, and my distance is in 25. So 10, 25 is here. 20, 50 is here. 30, 75 is here. And lastly, 40, 100 is here. Now, if I go ahead and connect those dots, what you notice, is that everything is in a perfect line, and look at that. It goes through the origin, which is what we need. So that shows that this is a direct variation. So yes, a direct variation. Okay, it is a straight line, which means the slope is the same, which means the constant of variation is the same, and it goes through the origin. So that means our y-intercept is 0. Perfect. Okay, now what we're going to do is look at the ratios, because the ratios have to be proportional. So to do that, we are looking at the relationship k equals y over x. So here we go. Let's do the first one. That has to be 25 over 10, which has to be equal to 50 over 20. This is my y, that's my x, which means that 75 has to be over 30, y over x. And lastly, this has to be equal to y over x, which is 100 over 40. Perfect. Now let's go ahead and see if we can reduce these. So is there a number that goes into 25 and 10? Yeah, I'm going to say 5 goes in there. Well, 5 goes in there 5 times, 5 goes in there 2 times. So what we're left with is 5 over 2. Okay, we need our constant of variation to be constant. It needs to be the same. So with this first ratio, it's 5 over 2. Let's look here. Is there something in common? I would say yes. 10 goes into 50 5 times, and 10 goes into 20 2 times, so we're left with 5 over 2. Hey, that's awesome. Those are the same. Perfect. Okay, let's go to this next one. What goes into 75 and 30? I'm going to say 15 does. 15 goes into 30 2 times, and 15 goes into 75 5 times. Hey, look there. We have 5 over 2 again. We just need this last one to work, and if it does, then it is a direct variation. Okay, we have 100 over 40. What goes into both of those? I'm going to say 20 does. 20 goes into 40 2 times, and 20 goes into 100 5 times. So that's our last one, 5 over 2. And if you can see, the constant variation is the same for all of these different ratios. So that means it's proportional, which means yes, this is a direct variation. All right. And we solved it graphically and looking at the constant variations and the ratios and making sure they're proportional in the table. So now it is your time, ladies and gentlemen, to check it out. You're going to have to do check it out example 1A and check it out example 1B. Okay, so let's go at it. Where's our friend? I think I can hear him. He's coming. He's coming. Oh, it's the pause dragon, and he's flying everywhere, reminding you that it's time to pause your device, electronic device, work these problems out, and then come back and see if you got them right. All right, good luck. Bye. Okay, we are back, and we are going to determine whether this data set shows a direct variation or not. We have Kyle's basketball shoes. Okay, Kyle. We're going to say that the distance is the x, and the number of baskets that he made is the y. The first thing we're going to do is just graph this data. So we have 1, 2, 3 points. The first point, oh, there's just 3 points. That's nice. The first point is 25. The second one is 33. And the last one is 40, 0. Okay, I went ahead and labeled this. Here's the distance for the x-axis and the number of baskets for the y-axis. Let's just go ahead and, this is in increments of 5 and this is in increments of 1. Let's go ahead and graph it. So the x is 20 and the y is 5. So for 20 feet, he made 5 baskets. 1, 2, 3, 4, 5. Perfect. When he was at 30 feet, he made 3 baskets. So here's 30 feet and he made 3 right there. And when he was at 40 feet, he didn't make any baskets. So 40 feet, 0 baskets. He probably should have shot a little closer. Okay, let's go ahead and connect the dots and see if we have a direct variation. Okay, and what I'm going to say is it really does not look like this point right here is definitely not on the line, and it does not go through the origin. So the y-intercept is not 0. The y-intercept's actually up here at maybe between 9 and 10. So this is not a direct variation, not a direct variation. Okay. So we had to prove it graphically and also through the table. So remember, we're looking at the relationship k equals y over x. So this is our y, this is our x. We're going to go 5 over 20. That needs to equal 3 over 30, which needs to equal 0 over 40. Okay, well, right off the bat, I see that this is just 0 over 40 is the same thing as 0. And if I look at this, 5 and 20, if I'm going to reduce that fraction, 5 goes into 5 one time, 5 goes into 24 times. I'm left with 1/4. And then this, 3 goes into 3 one time, 3 goes into 30 10 times. So yeah, these are definitely not the same. We got 1/4, 1/10, and 0. So this is not a direct variation. The constants of variation, the k, is not constant. Okay, so no, not a direct variation. Okay, now on to the 1B. If you got that right, awesome job. Okay, on to the next one. Let's look at it. What do we have? We need to determine whether this is a direct variation. We have ounces in a cup. So here's ounces and here's cup. This is our x and this is our y. Okay, first thing we're going to do is we're going to graph these 4 points. So our first point is 8, 1. Our second point is 16, 2. Our third point is 24, 3. And our last point is 32, 4. So if you look here in my graph, I have ounces here on the x-axis and cups here on the y-axis. I put the ounces in units of 2 and the cups are in 1. All right, so the first point is 8, 1. So I'm going to go over here, 8, 1. There we go. The next point is 16, 2. The next point is 24, 3. And the last point is 32, 4. Okay, I just need to go ahead and connect these dots very carefully. Okay. And if I do that, what you see is indeed this is a direct variation. Each of these points is on the line and it goes, the y-intercept is 0. So yes, this is a, I probably should have said this is a direct variation. Okay? Awesome. So let's look at the table. Okay, we need to make sure that the constant of variation, k equals y over x, is constant. It is the same. So I'm going to go y over x, which is going to be 1 over 8, equals 2 over 16, which equals 3 over 24, which is equal to 4 over 32. All right, we're just going to go ahead and reduce these fractions. This one is already reduced, so the constant of variation, which is y over x, is going to equal 1 over 8. Okay, let's see if we can reduce this one. Well, yeah, 2 goes into it. 2 goes in there 1 time, 2 goes in there 8 times. So that is the same, 1 over 8, which is awesome, but we need to keep going because all of these need to be 1/8. Now, if we look at 3 and 24, 3 goes into 3 1 time, and 3 goes into 24 8 times. So yes, that is 1/8 as well. And now for the last one, 4 and 32. What goes into those? I would say 4 does. 4 goes in there 1 time, and 4 goes into 32 8 times. So there's our last one, and they're all the same. So yes, this is a direct variation. If you got this right, awesome job. Yoke de ikimashita. We will see you next time. Goodbye.